First, I will explain about introduction of operating system. macOS is a Unix-based operating system developed by Apple Inc. for Macintosh computers. First released in 1984 as macOS, it was renamed macOS in 2016. It is known for its user-friendly graphical interface (GUI), reliability, security, and smooth integration with other Apple devices. Early versions of macOS focused on ease of use and introduced features such as folders, wireless networking, and file encryption. In 2001, Apple launched macOS X, which brought major improvement in security, performance, memory protection, and multitasking, along with the Aqua interface and dock. Today, macOS continues to receive regular updates that enhance feature performance and security.
Now I will explain about operating system structure. The macOS operating system is built on layered architecture that separates system functions into different levels. These layers include hardware, core OS, and kernel Darwin, application service and framework, user interface, Aqua, and applications. By organizing system components in this way, macOS achieves better security, stability, and efficiency while providing a smooth and user-friendly computing experience.
Now, I will talk about process scheduling in macOS. Process scheduling refers to the method used by the operating system to manage CPU time among multiple processes and applications. macOS applies several scheduling techniques to ensure efficient multitasking, system responsiveness, and stable performance. The macOS scheduler determines which process should be executed and how long it should use the CPU. Then, it prioritizes important tasks while ensuring that all running applications receive sufficient system resources. Moreover, it allows users to run multiple applications simultaneously, such as Safari, Finder, and Music, without significantly affecting system performance. As a result, process scheduling helps improve efficiency, responsiveness, and the overall user experience.
Key features of process scheduling in macOS. The first one is preemptive multitasking. macOS uses preemptive multitasking, allowing the operating system to interrupt a running process and allocate CPU time to another process when necessary. The second is priority-based scheduling. Processes are assigned different priority levels to ensure that higher priority tasks receive CPU resources before lower priority background process. The third is time sharing. The operating system distributes CPU time through small intervals known as time slices or quanta to improve multitasking efficiency. Multithreading support. macOS supports multithreading, enabling multiple threads within a process to execute efficiently and improve overall performance. The last one is XNU kernel management. The XNU kernel in macOS manages process execution, memory allocation, and CPU scheduling to maintain system stability and performance.
Next, I will explain about deadlock handling. The first one is deadlock detection. macOS does not use active detection algorithms like Banker's algorithm or resource allocation graph. Instead, it follows the ostrich algorithm, ignoring rare deadlock while relying on timeout and kernel monitoring. Second, deadlock recovery. When deadlock occurs, macOS minimizes disruption by breaking the waiting circle, releasing resource, terminating the smallest affected process first, and restarting the system only if necessary. This helps restore normal system operation efficiently. The third one is deadlock prevention. macOS prevents deadlock by avoiding unused resource allocation before it happens. The first one is reader-writer locks. It allows multiple readers at the same time, but only one writer. It will improve CPU efficiency. Second one is Grand Central Dispatch. It will manage using queues, reducing hold and wait situation. The third one, turnstiles. It uses priority inheritance to reduce waiting times and improve scheduling fairness. The fourth one is timeout mechanism. It will stop circular wait by releasing or retrying blocked resource. And the last one for deadlock handling is deadlock avoidance. macOS avoid deadlock using strict lock ordering, where resource must be requested in a fixed sequence to prevent circular dependence.
Okay, now I will explain about file and directory. macOS manages file and directories using a highly structured, secure, and user-friendly system. Behind the beautiful graphical user interface, macOS is built on a unique foundation, combining Apple's signature ease of use with the robustness of unique subsystem. Okay, now we move to the call file system in APFS, Apple File System. First, instant cloning. Copying a file doesn't duplicate the data immediately. It just creates a marker, saving space and time. Second, snapshot. Capture the file system state instantly for fast-time machine backups. And third, space sharing. Multiple volumes can share free space on the same physical drive, so the drive does not need to be divided into fixed partition in advance. Next, the directory and structure. Everything starts from the root and split into four main areas. First, application. Application is where app live, and folders are represented by a single icon. Second, user. User personal space contain user desktop, document, and download. Third, system. The core OS file completely lock down and protect from user changes. And lastly, library. Setting and support files shared by all users. Okay, now Finder and metadata. First, Spotlight indexing. macOS constantly read inside files and metadata so user can search and find anything instantly. Second, tags. User can label files with colors or keywords to organize them without moving them to different folders. And third, hidden extension. Use extension like PDF to launch app, but hide them visually to keep things clean. Next, permission and security. Permission and security divided into two parts. First, unique-based control. Every file has a strict read, write, or execute permission assigned to specific user. Second, sandboxing. Apps are isolated. They must ask for explicit permission before accessing folders like user documents or downloads. Okay, next, iCloud integration. Smart Storage automatically move all and unsafe file from user desktop or document to the cloud when storage is low and leaving a shortcut to re-download them instantly.